the electrode wire fed at the high rate, so molten tip of the filler wire connects or contacts the workpiece before the droplet can separate from the electrode. So it heats it up. What it's saying here is that it's heating it up. Okay, it melts the filler metal into a droplet of liquid metal, but the electrode fed at the high rate, so the molten tip of the filler wire contacts the workpiece before it can separate. So it's hot and turned into a puddle, hits the top piece or hits the workpiece, and then what happens is it causes the short circuit. So it stops, that way it pinches off. Okay? Arc's extinguished, and the metal transfer begins due to arc forces and surface tension. And that's where we get the pinch force that we were just talking about. I'd make sure to highlight or bullet point the pinch force in your book and understand it very well. Again, low heat minimizes distortion, burn through and spatter, kind of what we've been talking about the whole time. It can be used for welding steels, low alloy steels, stainless steel, light gauge metals, and non-ferrous materials as well. You know, aluminum, so forth. You can use several different forms of shielding gases, preferably one of the most economical ones, or the cheapest version, is just straight carbon dioxide. However, most procedures and most shops have moved away from the straight CO2 and they went to a 75-25 mix, which is 75% argon, 25% carbon dioxide. It's a little spendier, but it creates it helps create a lot smoother arc and also a much nicer weld appearance. Not quite as hot either, okay? So there's the short circuit cycle. Now again, this is happening so fast that you're not going to see it with a normal eye. It's just happening very, very quickly, okay? So I don't know that I've dealt with an enhanced short circuit transfer. Monitoring, so I'm reading off the bullets here, looking at the bottom two. Current technology allows the monitoring and control of amps and volts 10,000 times per second. That's pretty amazing stuff. Consistency is now more available. So as we go to the book, we catch up on something before we get further on this. Page 683, right-hand column, top paragraph. All shielding gases may be used with the short circuit transfer method. Pure argon and helium and their mixtures are used with thin aluminum. Carbon dioxide, or a mixture of 25% carbon dioxide and 75% argon, may be used in the welding of carbon steel. There is a growing use of helium, argon, carbon dioxide mixtures for the welding of stainless steels. Again, that's a trimix, okay? All right, now we can move on. I don't know if this will. I'm thinking it would. Maybe when we put it onto the side, it'll allow us to go through. Now, through this book as well, there's several options as you're reading the chapters. On the sides of the pages, kind of on the columns, from time to time, you'll see for a video of GMA post-transfer visit, so forth, okay? Feel free to get on that website and look it up. Okay, let's talk about basic welding equipment. Welding machine or power source. It can be an engine-driven generator, transformer rectifier, or inverter with a constant voltage output. The consumable electrode wire feed unit includes the controls, the welding gun, the hose and cable assemblies leading to a gun. So there's quite a bit of things that could go wrong, which is also sometimes if you're out there in the field welding, the good old-fashioned shielded metal arc welding method, it's pretty simple. You got a cable, a stinger, which is usually very simple piece of machinery or piece of equipment, and then you just weld it up. Here you have contact tips and liners and guns and you know, rollers and so forth. A lot of other mechanical properties that can go wrong out in the field. Make sure you have the right equipment or replacement parts if you're consistently doing field repair. Okay, GMAW basic welding equipment part 2 here. Cylinder, yeah, shielding gas, work lead and clamp, reel of electrode wire. We talked about this. We know at this point kind of what we're doing. All right, sustaining arc for FMAW, FCAW. I think that was supposed to be a GMAW, FCAW. So these are your 5 must control 5 items. I would probably write these down, take note of these. Proper arc voltage, current's going through the wire. Appropriate wire feed speed to replace. The wire melted by the heat of arc. Burn off rate proportional to current. Arc action proportional to arc voltage. Okay. So, let's talk about this a little bit real quick. Okay. A lot of times people used to say that, so we're running a constant voltage machine, so we're maintaining what voltage we want to set at. Say we're setting at 18 volts, we want to maintain 18 volts, constant voltage. Now a lot of people used to say the amps were, well, they would call the wire speed amperage. Now it's not exactly 100% true because there's also a lot of things that can vary, that can be variables within that, okay? So the resistance alone, what type of material, what type of conductor is it, flux core versus solid wire. Also the contact tip, is it worn, and so forth. But your arc length alone can make a huge difference on your amperage. So when I've tested welders before and I've checked their voltage, it's amazing to see the voltage fluctuation if they pick the MIG gun up, come back in, and the same on their amperage as well. You'll see the amps go through the roof, come back down. And the amps aren't at 260 inches per minute or anything. This is the way that we refer to it now. Almost everything nowadays is set to a wire feed speed, so and preferably in inches per minute. However, some machines will still have the 40-60% proportional, and so forth. Okay. All right.